It's a nice sunny fall day in the backyard of science. You can feel the heat coming from the sun, warming your body. Even the dog feels it. She's laying down here, soaking up the warmth. The heat that's coming from the sun that we feel is from ultraviolet radiation. And then it warms things up. And the reason those things feel warm is that they're emitting infrared radiation. Those two things are different, but talking about both those and understanding them will help us understand the greenhouse effect and how a greenhouse works. Feeling the heat from the sun and feeling the heat from the dog that she's warmed up in the sun, those are two different things. She's nice and warm because she's emitting infrared. The sun's warming us up because it's emitting a lot of ultraviolet. Let's head into the shed of science and see if we can make sense of that and figure out how a greenhouse works. Shed of science. Okay, before we go for the whiteboard talk on trying to figure out the greenhouse effect, let's have a look at this little mini greenhouse project that I built. This is a thing you could easily do with your kids to investigate the greenhouse effect and how greenhouses work. It's just a little pipe frame that I made from PVC pipe that I cut and glued together. And so you can see these joints here are just glued together PVC pipe. And then I wrapped it in cling wrap, just the cling wrap from the kitchen. And that cling wrap is transparent and it will allow light to pass through the inside. The ultraviolet light coming from the sun will pass through and warm up the inside of this, and then after the UV goes away at night, it'll emit the surface in there, the ground and the plant that's inside will emit infrared radiation, which then is trapped by this cling wrap and held in there. So what this would look like if we take it out here and put it on a plant of science is something like this. We take that greenhouse and put it on that plant, and over the course of the day that's really going to warm up in there as that ultraviolet light passes through the cling wrap, warms up the ground and the plant inside, and then as the sun goes away at night, the ground and the plant will emit that heat back as infrared radiation, just like the dog felt warm, but that'll get trapped in there because that cling wrap won't let as much of that infrared out. Now let's go in and see if we can make sense of how this works with a little whiteboard talk. Okay, so let's think about what we learned outside about how the radiation coming from the sun is ultraviolet radiation, and the warmth that we feel being emitted from objects on the ground is infrared radiation. So we've got the sun up here, obviously not to scale, and it's emitting what's called UV or ultraviolet radiation. So I'm going to draw that in purple. And ultraviolet radiation has a relatively short wavelength. So the distance between sorry, that's kind of sloppy there. The distance between the crests of the wave, of the electromagnetic wave, are shorter relative to visible light, for example, what we see from visible light. And so the radiation coming from the sun is this short wavelength UV. So we'll just write short wavelength ultraviolet, or UV, and it's high energy, and that's what warms things up. That's what we feel when something on the ground gets warm, because UV radiation is warming it up. Like when the UV hits the dog or the plant, it feels warm and it warms up, but then that object radiates heat, and when it radiates heat, it radiates it in another part of the electromagnetic spectrum. It radiates it in infrared. Infrared waves are longer in wavelength, so I'm drawing them with a much longer wavelength. So long wavelength infrared, or IR. So the waves have different characteristic properties. The incoming UV is short wavelength, the outgoing infrared is long wavelength. What happens with a greenhouse is when that plant warms up, because the short wavelength UV hits it and it emits long wavelength infrared, if we put a membrane over it, like this greenhouse that we made and it's got that clear membrane. That UV can pass through one way, so it can come through the sun and warm up the plant, but the infrared going out is blocked by that membrane. It doesn't make it out, so it holds the heat in. You feel this every day when you get in your car on a sunny day, and as soon as you open the door, it's really warm inside the car. That's because all of the infrared radiation from the warmed up interior can't get out through the glass, but the UV radiation from the sun can come in through the glass. So energy is coming in, but energy can't get out, therefore it warms up. That's how a greenhouse works too. Energy can come in through that glass or that cling wrap in the case of the one we made, but it can't get out when it's radiated as infrared. Now the greenhouse effect in the atmosphere is a little bit different, but it's the same principle. A lot of the radiated infrared radiation coming from the surface of the Earth is held in because of gases in the atmosphere. And the more of those some kind of gases, the more that that warmth is held in. So things like carbon dioxide and methane, things that are greenhouse gases, do a good job of holding that infrared radiation down under the atmosphere in the Earth while still allowing the UV to penetrate. So a greenhouse works because it lets the ultraviolet radiation come in, but keeps the infrared from going out, and it keeps your plants warm inside. You could do a really cool experiment with your kids. Make one of those greenhouses, put temperature probes inside and outside, see how it warms up, see how it stays warm overnight, and see how it helps your plants grow. So that's how a greenhouse works.